Why space is completely silent. Imagine floating in the vast darkness of space. You're surrounded by billions of stars, distant galaxies, exploding supernovas, and massive planets colliding. But there is one thing missing. Silence. Absolute silence. No explosions booming. No wind blowing. No sound of stars burning. Nothing. But why? After all, space is full of powerful events, massive collisions, solar storms, cosmic explosions. These should create enormous noise. So why can't we hear anything in space? Today, we're going to explore the fascinating science behind why space is completely silent, how sound actually works, and whether the universe truly has no sound at all. By the end of this video, you'll never think about silence the same way again. Part 1. What is sound? Before understanding why space is silent, we first need to understand what sound actually is. Sound is not just something we hear, it is a type of energy. Sound travels in the form of waves called sound waves. Sound waves are created when something vibrates. For example, when you speak, your vocal cords vibrate. When a drum is hit, its surface vibrates. When a guitar string is plucked, it vibrates. These vibrations push nearby particles, creating waves that move through a medium until they reach your ears. A medium is the material through which sound travels. Common mediums include air, water, metal, wood, glass. Without a medium, sound cannot move. Sound is actually the vibration of particles transferring energy from one particle to another. Think of a line of dominoes falling. Each domino pushes the next one. Sound works in a similar way. Each particle pushes the next particle, transferring energy through the medium. Part 2. How sound travels. Sound travels as a longitudinal wave. This means the particles vibrate in the same direction that the wave moves. When an object vibrates, it creates areas of compression, particles push together. Rarefaction, particles spread apart. These alternating compressions and rarefactions move through the medium as a wave. That wave eventually reaches your ear. Inside your ear is a thin membrane called the eardrum. The sound wave causes the eardrum to vibrate. Your brain then interprets these vibrations as sound. This is how we hear music, voices, and everyday noises. Part 3. Sound needs particles. The key idea here is, sound requires particles to travel. If there are no particles, there is nothing to carry the vibrations. This means sound cannot travel through empty space. On Earth, sound travels easily because our planet has an atmosphere filled with air molecules. Air is made up of tiny particles constantly moving and colliding. When something vibrates, these air particles transfer the sound energy. But space is very different. Part 4. What is space made of? Outer space is often described as a vacuum. A vacuum is a region with extremely low pressure and very few particles. Unlike Earth, space does not have a thick atmosphere filled with air. The density of particles in space is extremely low. There are only a few atoms per cubic meter in most parts of space. That is almost nothing compared to Earth's atmosphere. Because space has almost no particles, there is nothing to carry sound waves. No particles means no vibrations. No vibrations means no sound. That is why space is silent. Part 5. Why explosions in space are silent. In movies, space battles are loud and dramatic. Explosions roar, spaceships fly past with loud engines, and lasers make powerful sounds. But in reality, none of these sounds would be heard in space. If two planets collided in deep space, the event would release enormous energy. But the sound would not travel. Even a massive supernova explosion would be completely silent. Why? Because there is no air to transmit the sound waves. Astronauts watching the explosion would only see light. They would not hear anything. This is very different from explosions on Earth, where sound waves travel through the air to reach our ears. Part 6. Experiment. The bell jar demonstration. Scientists demonstrate this concept using a device called a bell jar. Inside the jar, there is an electric bell that produces sound. At first, the jar contains air, so the bell rings loudly. But then, scientists slowly remove the air using a vacuum pump. As the air is removed, the sound becomes quieter and quieter, until eventually, the bell becomes completely silent. Even though the bell is still vibrating, the sound disappears because there are no particles left to carry the sound waves. This experiment clearly shows that sound needs a medium. Part 7. Space is not completely empty. Even though space is mostly a vacuum, it is not 100% empty. There are still tiny amounts of gas and dust particles. In some regions, such as nebulae, the density of particles is slightly higher. Because of this, very faint sound waves can technically exist, but they are far too weak for human ears to detect. For example, scientists have detected pressure waves in galaxy clusters. These waves are similar to sound waves. However, their frequencies are extremely low, far below the range of human hearing. Humans can typically hear frequencies between 20 Hz and 20,000 Hz. Some cosmic sound waves have frequencies millions of times lower than this. They would take years to complete one vibration cycle. Imagine a sound wave that takes millions of years to produce a single vibration. That is how slow some cosmic sound waves are. Part 8. Can astronauts hear anything in space? Yes, but only inside their spacesuits or spacecraft. Inside a spacecraft, there is air. This allows sound to travel normally. Astronauts can hear each other speaking, equipment operating, fans circulating air, warning alarms. Spacesuits also contain air. Astronauts can hear their own breathing. They can hear their movements. They can hear vibrations transmitted through solid materials. Sound can travel through solids more efficiently than air. If an astronaut taps a metal surface, vibrations travel through the material and can be heard. But outside the spacecraft, there is silence. Complete silence. Part 12. Why silence in space is important. The silence of space actually helps scientists. Radio telescopes can detect extremely faint signals without interference. If space carried sound like air, detecting weak cosmic signals would be more difficult. The quiet environment allows scientists to study distant galaxies. Silence helps us understand the universe better. Conclusion. Space is silent because sound requires a medium. Sound travels through vibrations and particles. Space has almost no particles. Without particles, sound cannot travel. Even the most powerful explosions in the universe occur in complete silence. However, the universe is still full of energy. Instead of sound waves, space is filled with electromagnetic waves. Scientists convert these signals into sounds we can study. So while space may seem silent, it is still full of activity. The universe is not quiet, it simply speaks a language we cannot naturally hear. OUTRO. If you enjoyed this video, don't forget to like, share, and subscribe. Let me know in the comments. What space mystery should we explore next? Thanks for watching, and remember, in space, no one can hear you scream.